All right. So this is the next to last class. This will be the last lecture. Finish doing chapter 13. Next week, I'll just help people in the lab. And after that, the final exam will be available online, like the quizzes. Your scores are up here. Your ID is the last 4 digits of your student ID, not your social security number. And the people with green have already got an A. And the grading system is down here. So you need 585 for an A and 520 for a B and so on. And a lot of people have done extra credit to achieve that without taking it, which is fun. But you can if you like. It's 70 more points. All right. So, chapter 13 is here. And I think I better shut this door. All right. So we got a few people online and a couple people here, and no more will appear. So it's time to go. So this is security devices. These are the simplest kind of security devices. There are more advanced ones. We'll talk about routers, firewalls, IDSs, and honeypots. And it sounds like I better shut this door too. All right. All right. So if you have packets on a local area network, they travel by MAC address through switches and hubs. And that's what you see. Let me see if I can get my cursor to appear. I'll make this thing smaller so I can point around. All right, so you have a LAN here where they all have the same first 3 numbers or the same network address, and then they ask a router to get lifted onto another network. And that's what routers are for. They connect different networks. They're intelligent enough to look at the IP address and forward things, so they operate at layer 3, network layer. The purpose of routing is to find the physical location of a computer. So if you pick up your laptop and move to a different room and connect to a different network, you have a different IP address, and the routing is used to find where you are. You can use static routing, where the administrator has to type in to every router a list of what networks you can reach and which interface is associated with which network, but that only works for small networks that don't change much, like your home network. Companies want to have automatic routing protocols, so the routers automatically tell the other routers what they can see, reach, and how efficiently they can reach it, and they can decide to find what all the alternatives are and what the best path is. So open shortest path first is one routing protocol that is probably the most efficient for local area networks as far as open source protocols. It's a linked state routing protocol, which means that each router has the entire network diagram and it knows which links are up and which links are down. So it requires more RAM and CPU on the router than RIP, but it produces much more accurate routing. Before routers were powerful enough to run OSPF decades ago, they ran RIP. And RIP is a very primitive protocol. Well, in RIP, the routers cannot hold the whole map of the network. So all they know is if I have like 3 interfaces, this interface goes to that network in this many hops. And that interface goes to that network in this many hops. And they don't even know how fast the links are. All they do is count hops. And so they just know something like this: Norway this way, Mexico that way, Peru that way. That's all they know. And they will send something in what they hope is the right direction. And this was a pretty inefficient routing protocol, and among its many defects, it was slow to converge. It could take many minutes for it to notice a change in the network, and it could spend quite a period of time with errors in the routing table, so packets just go around in loops instead of getting there. On the internet backbone, it's different because you do not count hops or even transmission speed. What you count is the number of companies you pass through. So if you go from Sprint to AT&T to Comcast, that's going through 3 autonomous systems, and it's counted as such. And if there's a path that goes through only 2 autonomous systems, it would be preferred. And that's what Border Gateway Protocol does. That should be called protocol, not patrol. Mistake I got from an early textbook. protocol. And that's what routes the big hops from one company to another, from one country to another across the internet. It is not used on local area networks typically because it's difficult to set up, but it is what governs all the large transmission of network traffic in the world, and unfortunately, BGP is completely insecure. It's like ART or DNS or TCP. It has packets that are very important traveling through the network, advertising routes, and they are never authenticated. There's no signature, no cryptography, no password, no nothing. So anybody can send out a packet on behalf of another network and reroute it. And this happens over and over again. Every year or two, there's a major disaster caused on the internet by somebody putting out bad BGP packets. So there's a Chinese ISP that's done it again here, and this was in 2010. In around, I think, 2008, Pakistan brought YouTube down for an hour by advertising a false route to YouTube that caused all the YouTube traffic in the world to get sucked into Pakistan and thrown away. Here's a attack, a man-in-the-middle attack from Russia. So this is something you can do. If you want to, for example, read someone's Gmail, and they are in, say, the NSA's office in Maryland, you could decide that I want to take the traffic from Maryland that's heading for Google in California and cause it to go through Russia on the way there. And any internet service provider or any large company in Russia with access to BGP can advertise routes to make it to claim that the fastest route to get to California from Maryland is now to go through Russia first. And nobody in the whole system is smart enough to realize that they don't have the right to say that, or that that is stupid. The routing will just automatically happen and the traffic will go through there, and you can leave it do that for a while and then turn it off. And there have been several occasions where China did it for something like half an hour. So if you believe that there's something happening and you want to spy on a particular traffic, you can do it. And you might think that HTTPS would save you, because then, even if you get in the middle of routing, the stuff should be encrypted. But the problem is you can also sign it. If you are, say, the government of China, or I think the government of Russia, you can just get a root certificate from some trusted certificate authority in your country, and then sign with a apparently legitimate but fake HTTPS certificate. And that will fool everyone unless they are using Chrome, and you're one of the top 1,000 sites, because Chrome has built into it memorizing who should be signing the top 1,000 sites, or unless the website is using HTTP key pinning. You can use a header which says, the first time you connect, remember what my certificate authority is, and next time, if it's changed, pop up an error message. But very few people are using that. That isn't turning out to be very practical in practice. So this is probably happening periodically, although it's primarily something spies do to each other, nation states. Most criminal organizations don't have the capacity to do this. But there are many times people get caught with this happening, either because of mistakes or because of what really look like deliberate military attacks. And it is something Mudge went before Congress 20 years ago to tell them we're relying on the internet, but the entire internet is fragile because of BGP. Anybody could bring it down at any time, and there's no defense in the system. And although there were some people talking about creating a new protocol called BGP-SEC, there's nowhere near deployment. They haven't even agreed what it should be. This could easily be updated to something encrypted with some kind of proof, so that you can only change routes for a network you really own, and somebody can tell whether you really own it, but we're nowhere near that. So there's lots of these. Here's IP hijacking via BGP. This is a fun one. When we ran out of IP version 4 a few years ago, towards the end, they sold undesirable IPv4 addresses. And I was surprised to hear that, because I thought an address is an address, but it isn't. There were addresses like the one starting with 50 and the one starting with 1 that had never been used, and people thought they would never be used. So pirate websites were using them. Instead of registering with ICANN or IANA and getting a domain name and an IP address, you could just take a public IP address that nobody else is using and put up a server and put that address on it, and then send BGP packets saying send traffic here, and just have a website that people can go to without the approval of the committee. And the only problem would be they might eventually give that address to somebody else. And that's why the last addresses were undesirable. They were already in use by pirates. So you would already be on blacklists for having had malware and command and control centers of addresses that were supposedly fresh and never used. And another one was, there was a brand of router, a brand of IP phone that sent an a vast amount of traffic to an address that was 192.168.1.1 backwards through defect in the programming. So that one address could never be used. You'd just be flooded with junk traffic if you tried to use it. Anyway, this kind of stuff happened. Here's hacking team helped Battalion Special Operations with a BGP hijack. They were able to redirect traffic for it. If you don't know Brian Krebs, you should be following him. He does an awful lot of good reports about this sort of thing, and he covered one of these. There was a company that was a DDoS mitigation firm, and they had a bad reputation as sort of lunatic hackers. And what they did was they sent BGP updates to mess up other people's traffic to what they called mitigated attack. So, I mean, a lot of people do mess with BGP to misroute traffic, and I've never heard of anybody going to prison or being fined or anything for this. It's just rude in the community of network administrators, and they take whatever action they choose. When Pakistan brought down YouTube for an hour, these guys retaliated by taking the entire country of Pakistan off the internet for a day. But that was not a lawsuit settlement or anything. That was just the expression of the community of network administrators who sort of like a club decide, here's what we're going to do to punish that guy. All right, so these are the routers that run the internet. These are the older Cisco routers. The thing about these things is they're designed primarily to be durable, so you can put them in the rack, lock it up, and be using them 10 years later without changing anything, and a lot of people are. They just last for a very long time. So there's more than 1 million of an old Series 2500 still out there. It's an operating system and a computer like any other, so it has vulnerabilities. They're very rarely updated or patched. And they run this crazy thing called iOS, Internet Work Operating System, which looks like MS-DOS. It looks kind of like Unix, but it isn't either of those. It's their own independent operating system from a really long time ago, like the 70s or 80s. And if you take the Cisco classes here, you can learn to CCNA and learn how to program it. It's pretty simple, but it is pretty weird. And one might wonder, why in the world do they maintain their own operating system instead of just using something normal like Linux? And in fact, there's no good answer to that. It's just a tradition inside Cisco. And it eventually irritated Cisco engineers so much that a bunch of them rebelled and formed Juniper. And Juniper routers run BSD Unix. So it's normal operating system with none of this nonsense, and it's so much nicer than Cisco, but Cisco is the standard. So anyway, Cisco routers are designed above all to just keep the traffic flowing. So if anything goes wrong and if the router has no error handling, if there's any exception in the code, the router just reboots, throws away all the packets in progress, comes back up and moves the new packets through. This is why protocols talk about you should have a retry if something gets lost, because it is the natural operation of routers to throw away some of the traffic. It's not a lot. Even 1% loss is far more than it usually is, but some packets are just thrown away and they make no attempt to worry about it. Their main job is to just keep it flowing like a water pipe. So non-volatile RAM is what stores the router's configuration file, which is just a small page or two of text. So it's really, they have ridiculous amounts, like 16 kilobytes of storage in NVRAM. I don't even know where you get a 16 kilobyte memory chip, except in a dump from like decades ago, but they find them in Cisco devices. It's very strange. Then they have flash memory, which is like the flash memory you get on a USB stick. And that's, see, when the power goes off, the RAM forgets everything. And when you turn on the router, it has no hard drive. So it has to boot up. And what it does is it takes a compressed operating system off the flash drive, decompresses it, and puts it in RAM and runs. And that takes like 5 minutes because you're never supposed to turn them off. They're not intended to go down and up quickly. The flash memory holds the iOS. The NVRAM holds the configuration file, which is just the iOS commands, just a page or two of text. And then there's read-only memory available just to be used in case all that stuff is ruined, because it's pretty easy to corrupt the flash memory by making mistakes when you're trying to download a new version of the operating system or something. So or you might forget your password, and in that case you go into the ROM. The ROM has a limited operating system that you can use for emergency purposes, like to replace the contents of flash or to replace a lost password. There are interfaces. The router itself is just a box with a few of these processing chips in there and memory chips, and it has panels where you put in the interfaces, and they cost hundreds of dollars each. It's all intended for ISPs, not really for home use. And so you buy some Ethernet ports, you buy some serial ports, and so on to connect to whatever you're connecting to. And here's what it looks like. You show any config. You've got these Commands like IPX routing interface, each zero has got an IP address. Here's turning on RIP. You're specifying the network you're going to advertise and routing with RIP protocol, and so on. You just have a series of these commands. In this language, you have to learn to program these Cisco routers, and then you're ready to configure them. And you learn a lot about networking, so that's why I highly recommend the Cisco classes. You'll be much better at running networks after you do that, because there are a lot of subtleties that you do not get in, say, Microsoft certification or Security Plus or Net Plus that you get when you really take Cisco. Anyway, routers themselves can do some basic security filtering, which is not really intended to block attacks. It's intended to route traffic, like lanes and stop and go lights. So if you have a router here, you can specify that this router B and router A will only take traffic from this interface over here, not directly from the internet, and so on. So you can deny certain IP addresses that are not allowed to talk to the router, and then permit ones that get to the next line. You can do very simple things like accept traffic from certain IP addresses, from certain port numbers, and so on here. And that's just basic traffic control rules. I mentioned it before because when you're penetrating testing networks, you frequently find from the outside, you can only see a couple of devices like the email server and the web server, and you have to compromise them and then pivot from them. And from them, you will see more of the network because the router access control lists do not allow traffic from the internet to go directly to things like the database server. They have to pass through the public servers, and then the public servers forward requests that need its approval onto the other servers. So you can filter based on header information, source IP address, destination IP address, direction, whether it's incoming or outgoing, protocol, and port number. This is a very simple packet filter. This was the first generation of firewalls were called packet filters because they would do just this, just look at the header on the packet and decide whether it's okay or not. And those things prevent ridiculously simple attacks, but they don't stop very many modern attacks. So Michael Lynn caught my attention. This is why I ended up teaching this class. At DEF CON, he went there. He was an internal security researcher, and he found a bunch of vulnerabilities in the Cisco software, and management did not fix them fast enough for him, which is the story you'll hear over and over and over again. Hackers always find stuff, and they're always frustrated that management doesn't fix it fast enough. So he decided to present it all at DEF CON, and he got approval from Cisco, and then right before the conference, some lawyer said, no, you can't give the talk, and they sent FBI to raid the conference and try to grab all the CDs that had his slides, and he gave the talk anyway and got fired, but he didn't get prosecuted, and he got another job. But anyway, I got a copy of that talk and read it, and I said, this stuff going on in the security community is really getting pretty interesting, and I better start going to DEF CON and learn this stuff and teach classes about it. So I got a few cahoots about that stuff. Let me bring them up. My cahoots. There we are. This is the first one. And there we go. I'll turn on some of the glorious Kahoot music. There we go. So I got 3 in the room and 10 online. So it could be as many as 13 people coming in here. I'm going to find a pen. This paper in here, that's good. Seven. I'll wait maybe another 10 seconds. All right. I think I got whoever's coming. So let's take a look at it. 4 questions. So what protocol determines the worldwide path of the package? Yeah, it's BGP. Border Gateway Protocol is the only exterior routing protocol in the world used on the wide internet. All right, which one is a distance vector routing protocol? That's RIP, the very simple one. All the routers know is which direction to throw the packets and how many hops. They really don't know the full path, and so it's easy for them to get confused and make mistakes. That's RIP. The advantage of it is it works well on very old hardware with very little memory and very weak processors, because the router has a much simpler job than, say, OSPF. All right, so what component of a Cisco router loses data when the power goes off? Remember, that's the RAM. Same thing's true of any other device. RAM is volatile, and all these other devices retain data when the power goes off. All right, and what OS do Cisco routers run? Capital iOS. And why it's not Unix is a really good question. As far as I'm concerned, it should be Unix, and that's certainly the attitude of Juniper. All right, so Benham, P, Dan C, and Emmanuel. Will have to tell me who they are. Is Emmanuel in the room?
He's online.
What's that?
He's online.
He's online. He has a real name?
Yeah.
Okay.
He's teaching.
Okay. If it's your real name is Emmanuel, then I'll be able to figure it out.
Yeah.
Okay, good. I just thought for Christmas time it might be a pseudonym.
Oh, yeah. Oh, yeah. That's right.
Oh, yes. No, okay. There's his name. Good.
Oh, no, that's
good.
me. He's saying things.
Yeah, he knows you. Good.
Yeah.
All right. Good. Okay. Thanks. All right. Good. As long as I know who they are, I'm content. And let's do some more of these slides then. So then those are routers. Then there's firewalls. Now, the whole point of a firewall is to filter the traffic and deny and throw away traffic that's bad. You can filter, most people only run them on traffic coming in. It is rare to filter traffic going out, this is one of the many problems called the tragedy of the commons. If you want to protect your company, you want to stop attacks coming in. If you filter traffic going out, and it's an attack traffic, that doesn't benefit you any. That just means your infected machines can't hurt other people, so why should you bother? There's not much economic incentive to do it, and not too many people do. Although now what they do, which there is an incentive for, is they watch the outgoing traffic to see if their personal data is being stolen, and that's data loss prevention. And public-spirited citizens obey best current practice 38, I think it is, that says you should be filtering your outgoing traffic to stop your machines from attacking other people. And some people do that, but they're the nicer places like universities and stuff that are not directly motivated by profit. Anyway, so hardware firewalls are what you typically have on the outside of your network. You buy this thing, it looks like a rack-mounted device, looks like a router. And the point of this is it can run really fast. So you can run all the traffic like 10 gigabits for your whole network through this thing. And it filters out obvious attacks. Modern ones can also keep track of sessions and stuff. These things are getting pretty smart. But this is usually your first line of defense, is a hardware firewall to stop everything that is obviously evil from even entering my local area network, so I don't have to waste time processing it later. And you'll typically have more filters after this stage. It's very important to have defense in depth. In around 2000 to 2002, Microsoft's official instructions were what they call the M&M's network, where you have one firewall on the outside and no other layers of defense. So once you're through the first layer, that's it. You can just take over everything. And everyone has learned that's not good enough at all. You have to have layers of defenses. So when people get through, they can get to unimportant stuff, but there's another barrier between them and the important stuff and a series of barriers. That's the only way you have a realistic chance of detecting and stopping attackers before they get to your really valuable assets. Software firewalls can run on the servers and workstations and so on. They run, and those are the ones that often pop up these boxes asking the end user whether to approve it or not, which is kind of crazy for most end users that can't understand any of this. But anyway, they run on the operating system of the workstation and provide another layer of defense at that point. And all right, so there's one disadvantage is they have configuration problems, which is kind of a euphemistic way to say that if you pop up boxes like this, the end user will just click random things to get that box off the screen. And then they'll call help desk and say, it's not working. And they'll say, what did you do? And they'll say, I didn't do anything. Some junk popped up on the screen like it always does, and I got it off because they don't understand questions like this. Anyway, And of course, they depended on the OS. If there's an attack that compromises the OS, then they've also compromised the firewall. All right, so here are some technologies that were added as firewalls went through generation after generation to make them stronger, able to handle modern attacks. Network address translation became very popular. There used to be a thing called Wingate that started all this. In the early days of the internet, everyone was supposed to have a public address, and when it became feasible to manufacture cheap routers, people could actually start having many machines share one internet connection, which made it a lot cheaper for everybody. And so this is network address translation. The first version of network address translation would actually just take 5 public addresses and put them on your machines and translate them to 5 private addresses. So it didn't even save you any money. It had very little purpose. The most popular kind is NAT with PAT, network address translation with port address translation. This is what we're all used to do in a home network. So let me just move that out of the way. Let's shove this thing over there. All right. So if you have a, I'm not even really much good out of getting this thing out of the way. Just a moment. I'll try putting it down here and see if that gets it out of the way enough. Come on, stop messing with me. All right. So I'm having no luck whatever getting this stinking thing out of my way. This is the problem with broadcasting. I'll just make the slide smaller like this. All right. So you have people down here. This person opens a browser and their local port is 1100. This person opens 2 browsers or a browser and email. This is 1100. This is 1103. These are private addresses, 192.168.1.102. So they can't connect to the internet with an address like that. No traffic can be directed to those private addresses because they're used by many networks everywhere. They have to go to the router, and the router has to have a real public address that somebody had to pay money for to rent from an ISP. So if it's like our hacking lab, they're going through 147, 144, 21. So these 3 people open 3 sessions to the internet, and this is the source address that actually goes to those servers. They think they're all talking to 147, 144, 21 on different ports, and this device translates the address to the right address and the port to the right port. And that's why they call it network address translation and port address translation. And now multiple devices can use one network connection. Of course, the total bandwidth is just split among them. If you have 1 gigabit per second here, you've got a total of 1 gig for them all to share. But most people find that to be the most economical way to run their network. All right, so you can have access control lists again on a network. A typical home router, just like a Cisco router, you can filter by header information, source, IP address, protocol, ports, services, and that's what's called packet filtering. And that's what Windows Firewall does in its simplest case. It has it does more than this, but one thing it does is packet filtering, just like through certain protocols and block others. Now, stateful packet inspection is also included in Windows Firewall. This is where you understand what a session is, so you can look not only at the current packet's header information, you can look at the state table. And that's what your book gives you for a state table showing established connections. You can see them live. If I open a terminal on my Mac here and make this big, I can do netstat -an pipe more. And you see, here's the sessions here. So my local address is this 147 thing here. I'm connected to something on 443 and something else on 443. These are established connections because they're browser windows, probably that Kahoot. And here's ones that are waiting to close because I haven't used them in a while and they're timing out. And there are other states that pass it through, and you've done this in projects where you use SCAPI and make TCP connections. So now I can have firewalls that look not only at the packet, but they also look to see if that socket is in this table. Now this is called a socket. 4 numbers, a local IP address and port, and a remote IP address and port. Sockets are created by the TCP handshake. And once you've completed the 3-stage handshake, you now have this data structure created. And this means that this process on my machine can send machine traffic to that process on that machine as if we had our own cable. It's not encrypted necessarily, but it is separated by traffic rules so we can talk to each other without the traffic getting mixed up with other traffic from other processes, other machines. And that socket has a state, and that state can affect the firewall rules. So it's the Windows firewall. If you have it will not filter any outgoing traffic. So if I want to go to some website, I send it a SYN, it says SYN-ACK, and I say ACK. And now when it sends me traffic, it comes through because anything coming from an external website that is part of an established connection is allowed through. But if I didn't go to that website and ask for the traffic, it'll bounce off the firewall because something that comes in and is not a part of an established connection is blocked. So this way, your machine can be a client, but not a server, and that is typically what you want to be safe. This is the default Windows setting on a public network. If I turn on something like file sharing, the people in the coffee house can't see my files because the firewall will drop requests from the outside. But I can still use services. I'm not sharing any services with my firewall set in that mode. And that turns out to be extremely effective. Just that defense alone will make an unpatched Windows XP machine last for a year on the internet without getting infected. And if you turn off the firewall, it won't last a day before it gets infected. Yeah.
So nowadays, every firewalls are stateful, yeah?
Not all of them. There are some cheap, like I think the ones in your home router, like a Linksys router, I don't think it's stateful, but it might be now. Yeah. But yeah, most of them are. All right. So if you have a stateless firewall, then you can find out what's going on to some extent by sending ACK packets, because if it doesn't have state, a TCP transmission is SYN, ACK, ACK, then you send some packets and you ACK, then you send some packets up to the server and it ACKs. So there's data going one way and a stream of ACKs going the other way. And if the firewall doesn't have a memory, it has to let ACKs through, because for all it knows, that ACK is part of the data transfer in progress. So you can probe past firewall block rules for this kind of firewall with ACK packets. Now, the problem is ACK packets typically provoke no response. So you won't know you've gotten through. So what you do is you do firewall. You send an ACK packet with a TTL that's only one hop past the firewall. So it will penetrate the firewall, go one more hop, and then expire. And then you'll get an ICMP error message back saying, I threw away the packet. And if the network administrator didn't think to filter that, you will be able to see an IP address past the firewall. You can't do a port scan or anything. It's not terribly useful, but it is one of the defects of a stateless firewall. So stateful packet inspection is the next step, where you these stateful packet filters can look at the state table as well, and now they can handle that ACK packet and other attacks like reverse shell. And almost all valuable modern firewalls are layer 7 firewalls, and this is why Palo Alto is taking over and eating everybody's lunch. It used to be that you actually block port numbers and protocols, and that is for the birds. Nothing works that way anymore. People will hide their traffic on any port number it has to be on, so you need to actually block it by what it is. And a Palo Alto firewall has a big configuration page we can play with in the other classes, 140 class. We've got, it knows Facebook, Twitter, games, porn sites, BitTorrent clients, chat clients, proxies, and it also knows all your Active Directory groups. So you can say managers can do anything, the help desk can only do this, the secretaries can only do that, and sweep them around. It lets you handle real meaningful groups of websites and real meaningful groups of people, because it's much more complicated. And that means it's looking at the entire packet right up to layer 7. So if you have a BitTorrent and you move it to a different port, this still knows it's BitTorrent because it looks at the structure of the packet. It's not fooled by just changing the port number.
So,
yeah.
Sorry, so the packet goes through this firewall, and then you mentioned that it knows your username, but our username is not part of the packet that's going to the internet.
It's not, but it connects it to your Windows DNS server, your Active Directory server, and it finds out your IP address.
Okay.
You log on.
And then if two people are logging at the same time on one particular machine,
it cannot
with the same IP.
No, Windows machine cannot be logged into two domain controller sessions at the same time. When you log in,
I understand.
Yeah, so it knows who you are.
Okay.
Yeah. Now, if you were to have machines that were not domain joined, which I suppose you could have, then it would probably just have to filter them by IP address.
Okay.
Anyway, good. So if you only have one firewall at your company, like I said, that's pretty dangerous. What you typically want to have is a DMZ. This is the simplest case of defense in depth, which in fact, in realistic cases, gets much more complicated. Our college has 100 VLANs and 3 expensive firewalls and a lot of other, and also a software firewall running on every endpoint. So a DMZ is a network where you put in stuff that you need to make public, and therefore you can't trust it because it's likely to get hacked. Things like your web server and your email server. So you don't just put those on the same network as servers that contain really important data. You put public data on those servers and you isolate them from your internal network that has your social security numbers and proprietary research PDFs you've been making and all the things you really don't want people stealing. And that's what you call the DMZ. So you could do it with just one firewall like this, where you expose your email and web server directly to the internet unfiltered. And then you have a firewall limiting who's allowed to get into your internal network. But typically, you don't want to do that because that way a lot of really nasty attacks like DOS attacks and stuff will hit them. So you put it in 2 layers. You have one firewall here to filter the internet traffic, just to remove the obviously evil traffic to go to your web server, email server, and then you have another filter later that forces you to do something like authenticate through a VPN and prove that you really are a company employee before you get into the internal network. That's typically what you do, and in fact, you often do it many more layers than this. So there are a lot of these fancy firewalls out there. I've mentioned the Palo Alto. Cisco makes these. Cisco made the PIX firewall, which is very popular, and modern versions, the ASA. And it's got a banner that you can recognize that says you must log out immediately if you're unauthorized. People can recognize it by scanning the internet for that banner. And then you've got an access list where you just write these commands. They're again in this goofy Cisco language, so you have to get used to this stuff. But you have these things like unextended, deny IP, any log, and so on. These lines tell it to filter certain traffic and to log it. And so you can group objects again, like terminals and servers, and filter traffic to and from them. Missing an R there. And it's an expensive enterprise class device, highly valued. One thing, I've had students here that take the Cisco program and then they want to run the Cisco firewalls, and the problem with them is there is no packet tracing. There's no simulator. The only way to learn these things is to pay like $505 and use the real device, which is very annoying to students trying to learn this. All right, there are tools to help you get the configuration for your firewalls and routers. There are places you can go and download standard versions recommended for different kinds of networks. And there are router audit tools out here to see if you meet general standards. There are tools to audit your network. Red Seal is one of them. These are things that will just find out where all your devices are and how they're connected and what traffic is flowing between them. All right, and then there's IDS and IPS systems that are like antivirus for your network. They scan the network and try to detect attacks in progress and block them, or at least alert you about them. So you can have a network-based or a host-based IDS. The network-based IDS looks like this. You've got the traffic coming in through switches and hubs going to resource, and then you take an extra copy of the traffic from a hub or preferably a network tap, which is a hardware device designed exactly for this, and you send it to the IDS, which looks for attacks. And all it does is tell you if you're under attack. And the correct way to do this is to put no IP address on the IDS. You connect it at layer 2 with a MAC address. And the reason you do that is then when people scan the network, they won't see it. They cannot possibly take it over. Even if they find some kind of attack that would take over the operating system here, they can't make a session to it because they can't address it from the outside. It can only talk on the LAN. And you can do no way to detect it from the outside, so it's a very good way to monitor the network without the attacker being aware of it being monitored, and there's no way they can access it to erase the logs you record. A host-based IDS is software you put on a machine, like OSSec is one of them, a Tripwire is another, that runs on the server and tells you if it's been compromised by doing things like logging it, checking the internal logs and the MD5 hash of the system files and so on. A passive IDS just tells you that an attack is in progress by putting an entry in a log or sending a text message or something. An active system does something to prevent it, typically by changing a firewall rule, like blocking whoever's doing that. The Grow firewall they developed over in Berkeley, all they use to protect their network there, and all they do is if anybody sends attack packets, they block all traffic from that IP for half an hour, and they say that is really very effective. That's better. They don't have any static firewall rules at all. So there's a lot of IDSs and IPSs out there. McAfee makes them. Snort is a common open source one. Symantec makes them. There's a bunch of them out there. All right. And this, the entire process here changed greatly because of the Aurora attack. In December of 2009, China at this point had been hacking American companies for about 6 years, and everybody in the business knew it, but it was not officially admitted by anybody. Everybody covered it up as secret, sort of like Uber covered up their hack. They didn't want the shame of admitting that China had hacked them, so they would just quietly try to fix the problem. But Google didn't take that attitude because Google was expanding their business into China, and they were very uncertain about the wisdom of doing that. They had long internal debates and arguments about whether they could trust the Chinese, and they would get to do business in China, and then China hacked them, and they felt personally betrayed and angry that China would hack them when they'd gone out of their way to bring business to China, so they told the whole world. And they hacked back into the Chinese server and stole back the stolen data, which, by the way, was illegal too. And a Secret Service member I talked to, who came and gave a talk here, said, yeah, we told Google not to do that, but they did it, and we chose not to prosecute. But it does, like I say, it's not legal to mug a thief and steal the money back. It doesn't make it legal, but that's what happened here. And they found 30 other companies that had hacked, including pretty much everybody else you ever heard of, because proving what had been suspected but not openly admitted, which is the Chinese were just hacking everybody, which means all the defenses I just described were useless. The Chinese sailed right through it and took over everything. So here's, they trick a user into visiting a malicious website with something like a spam email. They click on a link. Now their browser gets exploited, so they have malware in the machine. Now it calls home to a server, so they have a user-level access to a workstation. Then they escalate privileges locally to administrator on the workstation. Then they find the Active Directory database and hack into that. And then they have cracked credentials from the Active Directory database. Now they can use VPN access to get into the internal corporate network on the other side of that second firewall. And now they can just steal all the data and send it back to China. And that's what they were doing to everybody. And none of these appliances I've described were capable of detecting this attack or stopping. So, at the end result of this is what they said we would have to do. And I remember laughing at this years ago, saying, you got to be out of your mind. Nobody could ever do this. And now we're all really doing this. And that's why I'm teaching a network security monitoring class. This is really becoming what you have to do. Inspect your DNS, watch internal network, control the traffic, have aggregated logs to a central point, have something like Snort running or QRadar so you see it. You audit all the traffic. You have a security operations team monitoring the network. You have an incident response team that kicks out attackers when they come in, and that's what you have to do to protect your network. It's crazy. It's like you have to have your own army, your own security team with quite a few people working. This is what you have to do if you want to stop attackers like Chinese military. They're really pretty serious attackers. And people are really doing this, and there's a lot of jobs in it. That's why I'm teaching the classes in incident response coming up next semester, I think, maybe the semester after, I forget, and the network security monitoring to learn to be on these IR teams to handle these advanced attacks. So that's right, that's the new class taught this semester. All right, another defense is honeypots. Another thing people do is they put deliberately vulnerable systems on the network so they will be attacked. There are two reasons to do this. One is because you're an antivirus company, you want samples of viruses. And another is because you just want to distract attackers for a period of time so you can have time to respond to them. So a honeypot is a computer placed somewhere that appears to have valuable data, but the data is in fact not valuable, and you hope attackers will waste their time stealing data from your honeypot. So it could be as simple as just a process running that answers a few network requests looking a little bit like a Linux machine, or it could be a whole virtual machine or a whole network of virtual machines all full of fake data. It can be as complicated as you want to make it. One thing, by the way, not in your book, but it's quite popular at security conferences, is to make poison honeypots, where you actually put malware on the honeypot, so when they steal that, it's going to crash their systems, or phone home to you and tell you who they are. And we've had interesting discussions at conferences about how legal that is. Suppose I put a Trojan on my server, so that if you steal it and unzip it, it will infect you, and then you'll phone home to me and tell me who you are. Is that a crime? I say, dude, I didn't make you steal it. It's not my problem when you steal it. I don't know the answer. I do know in New York City in the 70s and 60s, there was a guy who had like a Harlem store, and he got robbed many times, so he finally took a shotgun and tied it to the doorknob, so when people came in, they got shot. And the courts ruled that that was illegal. You're not allowed to be doing that, blowing away random people who just happened to open the door. So I don't know exactly how they would rule on this. If I put a malicious file on my server and blow up the computers that steal it, I don't know. None of this will be decided in court. But anyway, that's the game. So you can buy commercial honeypots like Spectre and NetBait, and there's open source honeypots. HoneyD is common. It runs on Linux. It's easy to run. It's a very weak honeypot. When you connect, it looks sort of like a Linux system, but when you start executing commands, most of them don't work. It's not very realistic, but it will confuse people for a while. And it also logs everything they do. So one thing people do is put up honeybee and then just sort of laugh at the kiddies running around trying to figure out what it is. All right, these are virtual honeypots, like I say, where you just run a software that looks over the network like a server, but there is no server there. Here's a project, which I think is the one Matthew Prince ran before he ran Cloudflare, where you would put extra email addresses on your website in comment tags so normal users won't see them. And the idea is people send spam by running bots which scrape email addresses off the internet, and then they send them spam, malicious stuff. They wanted to find out who was doing that so they could put them on block lists. So he made this system where you would put this software on your server, and it would add randomly generated email addresses to your page, and then it would connect to your logs so they would know when certain IP addresses had loaded that page. And then they would watch to see when you get spam to that email address. And when you do, it would correlate back to the server logs, and they would know who ran the server that scanned to steal addresses for illegal purposes. And then you can put those on block lists, an IP block list, and because they're among malicious actors. And that turned out to be very powerful and eventually led to the company Cloudflare, which is a more enhanced service that provides a similar service and more advanced services. Here's the HoneyNet Alliance is another one where you run machines, they get infected, it automatically detects the infection and sends a sample back for analysis. The antivirus companies and Microsoft also run a bunch of these for the same reason, to get the malware that's out there. And then there's web application firewalls, another defense, not in your book, but commonly in use and required. If you take a certain number of credit card payments per year, your PCI compliance requires you to have a web application firewall. A normal firewall filters on things like port number and protocol and whether it's BitTorrent, but a web application firewall operates always at layer 7, and it scans the incoming web requests for specific web attacks. And we have the class coming around web application hacking next semester, securing web applications. To talk about this, there's a lot of attacks that are not easy for a normal firewall to detect, like SQL injection. You put in a name, and the name has an apostrophe, and then it has or 1 equals 1 or something. That is not, a DOS attack. It's not a forbidden port number. It's a perfectly legitimate web request. There's a whole different list of bad things to block, and that's what web application firewalls do. They block these things as they come in. There's a bunch of them for sale. Barracuda's got them. Sphere's got them. So it's just like antivirus. It's got a list of attack signatures. It filters them, and it constantly updates the attack signatures, or it would go out of date pretty fast. And I mentioned there's Cloudflare is a service that will protect your web server with reverse proxies. So the result is when people try to go to my web page, they are not connecting to my server. They're connecting to a Cloudflare server, which has a copy of my page. And the Cloudflare server updates the copy as necessary, but nobody sends any packets directly to my server at all. And if you send any kind of attack, like a DDoS attack, Cloudflare handles it and does not send it to my server. So my server does not need to be strong or powerful or anything. And the main reason people use Cloudflare is not to protect themselves from attacks, but as a content delivery service. If you're a big company, you have customers all over the world, you want the people in China to have a local server. You don't want their traffic to have to come all the way to America to load the page. And Cloudflare has servers everywhere, so that everybody finds a server near them and they get a fast response, even though you don't have to pay for all those servers. You can have just one central server providing the copies of data that Cloudflare is handing out. And Akamai does the same thing, but Cloudflare does it for free to some extent. There's a free service in the free level and paid levels, so that attracts a lot of people like me that don't have much money. So I got the who here. And Cloudflare has very clever people. I'm very impressed with them. And they have one of my students there too, so they could have more. They're always hiring. If you are really sharp about Linux and you want a job, consider applying to Cloudflare. But you got to be pretty good at Linux. There's all Linux, and you got to be Linux server administration is the main skill that I see them do. But now they're hiring at a lot of other levels too. So check it out if you're looking for a job. And by the way, next Tuesday, there's a meeting worth going to about internships on campus. So check my website. That's in Multi-Use Building 140 at 6:30 on Tuesday. I highly recommend going. There are real internships coming that will pay. And you want to find out how to get ready and compete for those. 25 of our best students will go off to them and make more than $30 an hour for, I think, 18 months. And then probably be well set to get a permanent job out of it too. So if you don't already have a good job, you should come to that meeting and learn how to apply for these apprenticeships. Let's see. I still got the same number of people, so I think last time it went up to 10. I'll wait a little bit. There we are. I'll wait another 10 seconds. All right, looks like I got whoever's coming. 4 questions. All right, what technology includes a memory of previous packets? A stateful packet inspection. It has the state table, which depends on previous traffic. All right, what does Windows Firewall do? Does SPI. It's the same thing I just described. It is not just a packet filter. That was the before Windows Firewall. Back in the days of Windows 2000, you had a plain packet filter, and that thing was useless, and nobody used it, and they would download other things like ZoneAlarm. But since Windows XP Service Pack 2, we have a stateful firewall built into Windows and on by default. All right. Which one is intentionally vulnerable? That's a honeypot, of course, okay. And which system hides your web server so its IP address cannot be found? That's Cloudflare. All you go to my website, all you're ever going to get is Cloudflare IP addresses. You can't find my IP address. It's not in the DNS. At least it's not obviously in the DNS. Anyway, so E and Dave and William Pond. William Pond looks like a complete name. Dave and E better tell me who they are. Is E perhaps Emmanuel? You have to send me a text or something if you want to get your points. Oh, here comes a text. E is Dave. Okay, good. I got who David is anyway. And E, I got E also. Good, good. All right, folks. Well, that's it. I'm going to go to the lab and help anybody who wants to work on projects, and that's all I'm going to do next time. No lecture. So that's it. Have a good night.